Good afternoon, everybody. Yeah, I'm Mfon Akpan from Northeastern State University in Oklahoma. Unfortunately, my co-presenter, Kehinde Ogunade, is not able to be here today. Um, so I'm going to do this on both of our behalves. So this presentation titled Enhanced Risk Assessment explores how generative AI models can predict and interpret critical audit matters, or CAMs, using only the management discussion and analysis, or MDA, section from 10K filings. Now, there's been a great deal of conversation about AI and accounting, but this research focuses on practical use. So benchmarking models for practical use. We took multiple AI systems to see how well they predict CAMs and how well they perform in generating explanations aligned with auditor reported CAMs. So our goal is to give auditors, regulators, and firms data they can use to decide how and when to integrate AI into risk assessment. So what makes this study unique is the user interface perspective, or the UI perspective. So we tested these systems the same way a professional would use ChatGPT or Claude, so working directly with the interface. And this helps us to see how the products actually work and then where they fall short. So we've got two main research questions. The first being, can generative AI models predict the presence of one or more CAMs using only the MD&A text from a 10K filing? And if a model predicts a CAM, can it correctly match the CAM topic disclosed in the auditor's report? So can AI detect risk, but also understand the type of risk that matters to most auditors? Now, we found some recent papers to anchor our study. So the first was with Dr. E.G. from Texas A&M University. And what they did was they tested ChatGPT 4.0 in the API. So they tested how well ChatGPT 4.0 can predict critical audit matters using footnotes and disclosures. And what they found out was that ChatGPT 4.0 could predict CAMs 37% of the time. And then they divided up their output to AI CAMs, and then auditor AI CAMs, and then you have auditor CAMs. And then what they found out was that this category of auditor AI CAMs was linked to greater financial reporting risk. Um, so it demonstrated that machine reasoning can separate meaningful disclosures from boilerplate risk language. Dr. Barhava introduced an AI-induced disclosure pressure model. So they looked at AI as not only as an analytical tool, but a force that shapes how managers write the MD&A. So they looked at 108 MDA reports from large US firms, and they found that they were strategically uh, uh, polished and toned in a structure because they expect AI systems to read and judge them. So he put these pressures into three categories: exposure pressure, um, competitive pressure, and reputational pressure. This paper was one of the reasons why we chose to use the MD&A as our source. The other was from Dr. Burke and colleagues, and they asked whether or not CAMs even inform investors. So they did an archival analysis, and they find that there's limited market reaction and minimal improvement in audit quality following a CAM disclosure. And they call this effect pseudo transparency, so compliance without communication. The final was my pilot study that I completed earlier this year, where I did 27 firm year observations with O3 Mini High reasoning model from ChatGPT. So I found out that AI or ChatGPT, that particular model could predict CAMs with an F1 score of 0.74, which was modest. So with these studies, this was a springboard that led us into this benchmarking project where we're scaling across models, well, 4 models and then 4 industries, looking at the predictive and generative performance. Now, while the prior research is looking at the ability to detect CAMs, none have looked at reasoning models to standard generative models. So we wanted to determine whether reasoning capabilities, so the models that are trained to think through complex relationships, actually produce better predictive results in auditing concepts. So, oops. Yeah, so the models used, and I put the dates there to kind of give some context. The model used was OpenAI's O3 Mini High Reasoning version, which was available from January to April of this year. And then OpenAI's O3 Pro, which was released in June. We also used Gemini 2.5 Flash, which was launched about April of this year and is still active today. And then Claude Sonnet 4, which was released about May and is still active. So the important part of this is that O3 Mini High was replaced by O4 Mini in April of 2025, as well as the O3, which was introduced in April, followed by the O3 Pro in June, and then ChatGPT 5 arrived in August, along with ChatGPT 5 Pro. And when we talk about token context, the O3 Mini High at that time had a 200,000 token context window with 100,000 output tokens. The same configuration for O3 Pro. Gemini 2.5 Flash had a 1 million context window with a little over 65,000 output tokens. And then Claude Sonnet 4 varied by user if you're using the free version. And then paid users had up to 1 million context window with 64,000 output tokens. So it's important to remember with the Gemini 2.5 Flash and then the Claude Sonnet, we were using the free version. So I wanted to emphasize. And with the O3 Pro and the O3 Mini High, this was accessed through, at that time, it was called ChatGPT Teams, which is their business. Well, now it's called ChatGPT Business. So which is their small business model. And I have 2 seats on that platform. So we tested these models under real world conditions, meaning no APIs. I don't know. Can you, oops. There we go. Thank you. No APIs and no pre-processing of the data. So we use the raw MD&A text. So this is copy and pasting the MD&A text directly from the SEC filings and also copy and pasting the prompt into the context window. So this was to maintain ecological validity. So we wanted the results to reflect someone actually using the UI. We also had to manage throttling, token caps, and then weekly usage limits, especially with these high compute loads. So our data set included 140 firm year observations across 4 industries. Each model received the same MD&A text and prompt with 0 shot prompting, so no examples, no prior training. And then we compared the AI predicted CAMs with the auditor disclosed CAMs using precision recall, F1 score, and binary accuracy. So with the prediction workflow, okay, with the prediction workflow, we input the MDA text, we prompted the model. The model would either give us the output, either a CAM, or it would say that no CAM exists. Then we compare the results to the auditor's report using a confusion matrix. So in the confusion matrix, we'd have the true positive. So the true positive would mean both the AI and then the auditor reported CAM, they match. False positive, they do not match. And then we had a false negative where the AI would say there is no CAM. And then there's no true negative. It was not applicable because all auditor CAMs were reported. Oops. Oh. Oh, sorry. This is an example of what our data collection would look like. So we have Apple Inc. We have the auditor CAM. If it matches with the AI CAM, then we've got a true positive. And then with Coca-Cola, if they do not match, then we've got a false positive. Went over that. So the evaluation framework, we use predictive performance. So this is measuring, it's pretty straightforward, measuring how accurately the model matched the auditor reported CAMs. And then the generative performance, we measure how effectively the model produced new CAMs. So risk areas other than no CAM that were not in the auditor's report, but still demonstrated audit relevant reasoning. So here are the results. And the predictive results are ranked by F1 score. So O3 Mini came out on top with 0.74, O3 Pro and Claude Sonnet 4 were tied at 0.72. And then last we have Gemini 2.5 Flash. So O3 Mini High emerged the strongest predictor. As far as the generative results, we had O3 Pro on top, and then Claude Sonnet matching it, and then Gemini 2.5 Flash and O3 Mini High. When we looked at the four industries, technology led, and then finance, and then consumer discretionary, and then healthcare. So there was a big gap between technology and healthcare. This could be due to industry disclosure style, data density. So we have to further investigate that. Let's see. So we found out technology seemed to have the highest rating, and then finance, and then consumer discretionary. So looking at the O3 Pro and then the Claude Sonnet, they were strong in both predictive and generative areas. Gemini 2.5 Flash did not perform very well, and then O3 Mini High was weaker on the generative side. So O3 Mini High was the best predictive model out of this, and then O3 Pro and Claude Sonnet 4 best generative models. Gemini 2.5 Flash underperformed. There's an industry variation between tech and healthcare, and the real world constraints impacted reliability. Let's see. Yeah. they generated a CAM. So the predictive was, what did they get right? The generative, did they generate a CAM at all, any type of CAM? So the AI could choose to generate a CAM or say that there is no CAM. So we're looking at their ability to add more insight. Thank you, everybody.